This video is a continuation of the last video, and in this section we are finding the cosine of s plus t and the cosine of s minus t given certain information. So in this example we were given the sine of s and the sine of t. So I'm going to write that information over here. The sine of s equals 2/3. The sine of t equals -1/3. We're told that s is in quadrant 2, so when we find our cosine, quadrant 2 cosine is negative, so I'm going to just put that here. And when we find cosine of t, we're told that t is in quadrant 4, so my cosine should be positive. So I'm just putting those there just as a reminder. And I know when we find the cosine of s minus or plus t, I need the cosine of s, cosine of t, the sine of s, and the sine of t. And they only gave me, oh, I'm sorry, I even wrote that down. No, I wrote it right. They gave me the sine of s and the sine of t. So they only gave me this part of my my formula. So now I'm going to use my Pythagorean identities to find the other part. I've got sine squared s plus cosine squared s equals 1. Sine is 2/3 squared plus cosine squared s equals 1. I get 4/9 plus cosine squared s equals 1. So cosine squared s is going to be 5/9. So when I take the square root, I'm going to get -5/3, negative radical 5/3, sorry. So now I'm going to do the same thing, but I'm going to do it with t instead of s. Not going to just let me erase that. Okay, so sine of t, sine squared of t plus cosine squared of t equals 1. So I know the sine of t is -1/3, and I need to square that. So when I square -1/3, I get 1/9 plus the cosine squared of t equals 1. Cosine squared of t is going to be 8/9. And I need to reduce this. All right, so when I take the square root, I'm going to get 2 radical 2/3. Right, so I have all my values. I'm just going to plug them in. So I get cosine of s is negative radical 5/3. The cosine of t is 2 radical 2/3. I'm going to add to that the sine of s, which is 2/3, and the sine of t, which is -1/3. So I'm going to end up with a -2 radical 10/9 minus 2/9. And if you want to join it in as one fraction, you're more than welcome to join it into a single fraction. So now if I wanted to find the cosine of s plus t, I need the cosine of s, cosine of t, there I go again, wanting to write sine, cosine of t, minus the sine of s, sine of t, and these are just our original values, right, that we ended up with, added. Oh, did I forget to add? No. Yeah. Geez. Okay, so this is going to look like this. If I'm going to do this, I have to do this right. So it's -2/9. Okay, so I got -2 radical 10/9 when I multiplied the cosine of s, cosine of t, and then I got a -2/9 here. So now here I have to subtract instead of add. So I get -2 radical 10 plus 2/9. All right, we have one more example, and that's all we have. Again, they gave us the cosine of s, which is radical 2 over 4. And then they did not give us the sine of s. They did not give us the cosine of t, but they did give us the sine of t, which is negative radical 5 over 6. Okay, and they told us that both s and t are in quadrant 4, so the sine of s should be negative, but the cosine of t should be positive. So let's use our Pythagorean identities to find the sine of s. The sine squared of s plus the cosine squared of s has to equal 1. Sine squared of s plus radical 2 over 4 squared equals 1. Sine squared of s plus 2 over 16 equals 1. I'm not going to reduce that because I'm going to have to take the square root, and I want a perfect square of my denominator so I don't have to rationalize. So sine squared is going to be 14 over 16. So when I take the square root of that, that's going to be negative square root of 14 over 4. So now let's go ahead and do the same thing, but for t, we will find the cosine of t. So I know whoops, there was a delay there. Like there's a delay here. All right, so sine squared of t plus cosine squared t equals 1. I know my sine is negative radical 5 over 6 squared plus cosine squared t equals 1. So I get 5 over 36. Remember, when we square a negative, it's going to be positive. So be careful there. And then I get my cosine squared of t equals 31 over 36. So when I take the square root, I get a positive radical 31 over 6. So now I'm just going to go ahead and plug my values in. Cosine, which one do we find first? The subtraction. Cosine of s minus t equals the cosine. Why is it doing that? Cosine of s, cosine of t plus sine of s, sine of t. So my cosine of s is radical 2 over 4. My cosine of t is radical 31 over 6. My sine of s is negative radical 14 over 4. And my sine of t is negative radical 5 over 6. So when I do that calculation, I get the square root of 62 over 24 plus, and this is going to be what the first side, the left part of this addition is, plus I'm going to get the square root of 70 over 24, and that's the other side. These can't really be simplified, okay? So I'm just going to write them as one fraction. So now I'm going to find the cosine of s plus t, and I know that's the cosine of s, cosine of t, minus the sine of s, sine of t. These are the values, right? Because this is the same as this, so it's radical 62 over 24, and then I'm going to subtract radical 70 over 24. I'm just going to go ahead and put that in one fraction since they have the same denominator, and that's my answer. That's how I would like you to do these problems on your homework.